my advice on these actually be to start off with the boundaries, okay, that boundary line, and to put a dotted line where your boundary goes. Okay, so if we know I'm going to have one of the graphs to the left of 0, one to the right, just put a dotted line just to represent where the boundary is. Okay, so I'm going to have, let's see here, if x is less than 0, so that means that's the one to the left. Okay. That graph of negative x plus 2 will be on the left side of my dotted line. And then same thing here, greater than is going to be to the right. So the graph of 1/2 x plus 3 will be on the right. Now there's a couple methods people do. Some try to do the domain and the function at the same time. Others just like to draw out the whole function and then erase what shouldn't be there. So they'll put the line across the whole graph, and then they'll say, okay, it should only be to the left side, and they'll erase that part. I'll leave that up to you, what you want to do. So here we go. So we got to know that negative x plus 2, and that's the same as negative 1 over 1 x plus 2. Got to know the slope and the rise and the run. So I'm going to start at 2. It's going to be a closed circle, because it's an equal to. And you'll notice if I use this slope, it takes me to the wrong side of the graph. I'm trying to do this on the left side. If I go down 1 and right 1, down 1, right 1, that's going to have me graphing on the right side. So we have to know another fact about slope, that a slope of negative 1 over 1 is equal to positive 1 over negative 1. So I can go up 1 and left 1. Up and left, and that'll keep me on the correct side. That'll keep me on the left side here. Okay, so just as I wrote out in the beginning, this graph should be on this side. And there we go. Use a straight edge and write the graph. Okay. Do the other side. So 1/2 x plus 3, start at positive 3, open circle, okay, open circle, and then up 1, right 2, up 1, right 2. There we go. That up just a little bit. There we go. There's a uncompleted problem. So several steps. Draw the boundary line, and then draw the left. So I usually graph them from left to right, but it doesn't really matter what order you go in. The graphing part is all review, how to actually do graph negative x plus 2 and how to graph 1/2 x plus 3. That's all review. Sometimes you'll have to move the negatives so you graph on the correct side of your boundary line. You have to know that negative 1 over 1 is the same as 1 over negative 1. Okay. So I'll do one more, a little bit faster. Okay. Boundary line. Go is at 0 again. And so I know this will be on the left side of this boundary line because it's less than. And these aren't always in this order. Okay? They're not always in this order. So negative x, we have to know that that's y equals negative 1 over 1 x plus 0. And once again, if you try to start at 0 and go down 1, right 1, that'll have you graphing on the incorrect side. You want to stay with the green only on the left side. So we'll have to know that. Instead, I'm going to graph up 1, left 1. So I'm going to start at 0 and go this direction. And here we go. 2 is 2 over 1. So start at -2 down here, open, and then up 2, right 1, and draw that. There we go. Okay. Not so bad when you see the final finished product, but there are a lot of little steps. All right, so this is the first one on your page. Let's go ahead and do it together. All right, so boundary line first. This time it's at 2. So draw that. Alright, so I know the top one, which is less than 2, that's going to be to the left. Less than is left. And y equals x will be on the right. I have to know that this is y equals -1 over 1x plus 0. Now I want to have this on the entire left side of the dotted line. Everything on the left side. So start at 0. I can go, this time I can go down 1 and right 1. I'm not going to cross. And it'll be a solid dot here because it's equal to. Next one. Just like the other one, we have to know this is y equals 1 over 1x plus 0. That's what y equals x is. All these other numbers are implied. So here's the catch though. If you start at 0, you notice you can't put a dot here because we're on the left side. We can only graph the purple to the right of this graph. So I'm going to have to just kind of remember that, okay, I'm starting at 0, up 1, right 1, don't put a dot, up 1, right 1. And once you get to the blue line, that's when you can start the graphing, and it's open. And they go up 1, right 1, and continue. So even though it has a y-intercept of 0, I don't want to mark it there because I'm not on the right side. That's why I drew this arrow here, is because this can only be to the right of that line. Any clarifications needed on what I just did? Why did I do that? How come that? What if you change this? What happens when? Any of those type of questions? Yeah.
Is there ever the case where they're both on the same side of
No, they'll never have graphs on the same side because then it wouldn't be a function. So everything we do has to pass the vertical line test, meaning if I draw a vertical line, it can only go through one at one point. So you'll never have it where they're both on the same side. Okay, so where one stops, the other one will begin. And you won't have any gaps between one or the other. Reminder, you can go to Desmos or download the app right now, and you can type in your two functions, right? And once you just type them in, let's see here, how do I change? No. Once you type them in, you can see, well, it just has the two lines crossing because it doesn't have the domain. So for the domain, make sure you use these type of brackets, and then you can put them in. Okay, this has to be x less than 2. Is that what it was? Oh, negative x is on top. That's fine. This one, x less than or equal to 2. And this one's greater. Right. And of course, if what you graphed matches, then you're on the right track. But if you put in Desmos and you get something that's completely off, you want to compare and see maybe what you did wrong, what happened. Maybe did you graph wrong, or did you have domain wrong? There's a lot of little things going on, but I would really like you guys to use this as you go along. If you have it, if you have a smartphone right now, go in and download it. It's free. And if not, use computer at home or in the library or in a teacher's room after school. And as you go along, check these. I don't want you doing all these wrong and finding out tomorrow when you come in, you're just trying to erase everything, copy down the right answer. But of course, that's not going to help you do anything correct on a test or a final just by writing it down. You really have to check as you go along, and this is one of the best tools for that, okay? Along with helping each other, of course. Okay, so I'll let you guys work on the next 3 on there, front and back. The last one has 2 domains, so you have 2 dotted lines. So just use your homework from last night, because there are some that had 3 on the back there. So use your homework from last night on the back to help you. We're just going the reverse direction as we did yesterday. Okay, so go ahead and get started on that. We'll be walking around to help you out as needed. So here's your homework. I highly recommend you start off by marking your boundaries. So start off with your domain and just putting that line. I know it seems like it's something simple, maybe something you just can keep in your mind, but it will change. So like on number 2, it's at 2. And then when you go down to number 4, the boundary's at -1. It's a really good idea to mark it. Technically, these dashed lines I'm drawing are not part of the graph. They're not part of the function. It's just something there to help us while we're graphing. So eventually, by the end, when you get really good at this, you won't have to draw it anymore. But for now, really good idea to go through and put that down. Some of you notice how over here there's 2 of them. So there's a boundary line at -1 and at +1. This is very similar to what we did in the homework, the notes. Same thing over here. We have a boundary at 0 and at 4. One, 2, 3, 4. And then go through and mark where each one goes. So I know that the 2 is going to go here. The 4 is going to go in the middle. And the 6 is going to go on the right. The 1 is going to go on the left. 1/2 x plus 2 is going to go in the middle. And the y = 5 is going to go on the right. So just draw arrows to where each graph should go, and then you can go through and graph it. When they're just a number, that's the easiest one to graph. It's just a horizontal line. So like y = -1. That's it's pretty straightforward right there. Y equals 5. 1, 2, 3, 4, 5. That's pretty straightforward. Now you just have to figure out the open closed circles and the middle, the 1/2 x plus 2. Okay, but you can see you can go through these. You get faster and faster depending on if the functions are simple, just a horizontal line, but if they have slope and y-intercept, sometimes it's more in depth. There shouldn't be spaces horizontally between the graphs. There can be spaces vertically. We saw that. So one might end here and then it starts up here, but you can't have any spaces horizontally. Like if this is our final answer, that would be wrong because there's a big old space here. There has to be something here connecting. And of course, you have a tool at your disposal. You don't want to abuse it though. It's like having a calculator. You don't want to just throw everything in there and say, oh, the answer's 5. Oh, look, I got the graphs. And I pass out a quiz or final with all that on there, and you're like, oh, I don't know. I guess when you retake the class, you'll, do it all over again. So you got to use the tool properly. You can't abuse it. So sketch it out, give it a shot, then plug it in to see if you're right. Use it to check your work, not to do your work. All right? There you go. Have a good one.